Hi, welcome to our Algebra 1 series. Today we're going to talk about functions and relations. A relation is any combination of inputs and outputs. So think of like, you put something in, you get something out. Think of ordered pairs like 1, 2, or 7, -4. Those are inputs, outputs, so that's a relation. Tables. Vending machines are also a relation. But our big focus today, and for this week, the big idea is about functions. A function is a relation where each input has exactly one output. That's a question you're going to be asked a lot. How many outputs? Exactly one. So let's look at a vending machine example. A vending machine is a relation because you put in something, you put in money, and you get out something, you get out movies in this case, or maybe it's a soda, or maybe it's, I don't know, chips. But what you put something in, you get something out. So you have an input and an output. In this case, I put in money, and I push a button, and I get some off-brand movies. So what DVD would you receive if you inserted your money and pressed A1? Well, you would get the Hunger Sports. What about C2 and B3? So C2, if I put in my money, I press C2, I'd get the Light Night. And B3, I would get the Amazing Insect Man. So I have some inputs, my money, and I get some outputs, movies. So let's assume that this is a good vending machine. It's working, it's stocked properly, all the movies are in the right slots. What would happen if I put in my money and I pressed the same button and I did that twice in a row? So let's say I put in $5, I hit A2, I get the Revengers. And then I put in $5 more, I hit A2 again. What would happen? Well, I would get the same movie twice. You get the same movie twice. Assuming again that it works correctly. So each input has exactly one output, if you have movies here. So this input only has one output. A2 only gives you the Revengers, or B3 only gives you the Amazing Insect Man, or C1 only gives you the Dependables. So every time you press a button, an input, you receive a DVD, an output. So in this specific DVD vending machine, does every single input give you one output? So whatever button you press, whatever input you put in, would you get an output? Would you get a DVD out? Well, no. B1 has no output. B1 is sold out. So that one has no B1 sold out. That one has no output. I can put an input in, but I would get no output. So is this a function? Does every input have exactly one output? No, this one doesn't have exactly one. It has 0 outputs because it gives out no movies. Okay, let's look at some different ways we can talk about functions. We can do tables, we can do mappings, we can do graphs. So here, on question 4, each combination of input and output can be expressed as a mapping, where my inputs are on the left, my outputs, the DVDs, are on the right. So for example, B2 goes to the Amazing Insect Man, A2 goes to the Revengers. What is it? C1? C1 goes to the Dependables. And B3 goes to the Amazing Insect Man. So A2 goes to the Revengers, C1 goes to the Dependables, and B3 goes to the Amazing Insect Man. So you can see that each input here, really just focus on the left side, these inputs. Each one of these inputs has exactly one arrow coming out of it. Each input has exactly one output. Let me draw a couple examples. A function is a relation where each input is paired with exactly one output. So looking at these examples that I'm about to draw, look at the inputs on the left. Does each input go to exactly one thing? Is that a function? Well, no, because B goes to 2. B has 2 arrows coming out of it. B goes to W, B goes to Y. Now you could also write these as ordered pairs. You could say 1 goes to 2, A goes to 4, B goes to W, and B goes to Y. And you'll notice that B shows up twice. It has 2 outputs, so that does not work. Now here's another one that I try to trick students with on our in-class assignments, just to get you thinking. Is this a function or not a function? So check this out. Is that a function or not a function? Does every single input have exactly one output? And now everything goes to one thing. Everything goes to W. But what I want you to focus on is just the left side, just your inputs. So I'm going to cover up the outputs. Look at your inputs. Does 1 have a single output arrow? It does. Does 6 have a single output arrow? Yes. Does A? Yep, A has 1 output arrow. And so does B. It doesn't matter where they go, as long as each one just has a single output arrow coming out of it. So even though they all go to W, this is still a function because each one of these only goes to one thing. There's only one arrow coming out of each input. Or if I did ordered pairs, 1 goes to W, 6 goes to W, A goes to W, B goes to W. None of these are repeated. They all show up once because they all have one output. All right, I'm going to ask you to pause the video and try to identify, is that a function or not a function? On C and D, see if you can identify if it's a function or not a function, and then unpause and check your work whenever you're ready. Okay. Now if I look at C, that one should be not a function because 1 and -5 both have 2 outputs. And D should be a function. Again, even though some of them go to the same thing, just look at the left side, just your inputs. How many arrows do you see coming out of each one? Just 1. And that's good. I want exactly 1 output. All right, now we're going to try something a little bit different. We're going to talk about real-world functions. So if I map cities in the United States to Major League Baseball teams, would I have an input, a city, that gives 2 different outputs, teams? So let's talk about baseball teams. LA, there's the Dodgers and there's the Angels. We'll do Dodgers and Dodger blue. Dodgers, Angels. New York, you got the Yankees and you got the Mets. In Oakland, you have the A's. And in Chicago, you got my favorite team, the White Sox. And you've also got, of course, the Cubs. So look at each city. Does each city have exactly 1 output? Does each city have exactly 1 team? No, that doesn't work because Chicago and New York and LA all have more than one output. They all have more than one MLB team. What if I flipped it around? What if I said, let me do this, let's go Sox, Cubs, I'm going to cut out the A's. Sorry, A's. New York, LA, Chicago. What if I flip it around? So this we said was not a function because I have an input Los Angeles with 2 teams. I have another input New York with 2 outputs, and Chicago also has 2 outputs. That's not okay. But what if I map every baseball team to its city? Does every team get exactly one city? Does every input get exactly one output? And yeah, the Sox only go to one city. The Cubs only live in one city. The Yankees are only at home in one city. The Mets are only at home in one city. So each team there would have exactly one output. So yes, that would be a function. Now what does that look like on a graph? On a graph, our inputs are X and our outputs are Y. So what I'm going to do is I'm going to use a vertical line. Let me do it in pink. And I can test if each input has exactly one output by dragging a vertical line, maybe your pen or pencil or your finger, across a graph. And if my graph ever hits the vertical line twice at the same spot, like it does here, then that's bad. This is bad. That means it's not a function because this input of 2 has 2 outputs. So that's bad. And we call this the vertical line test. So again, I'm going to take a vertical line, and I'm going to drag it across the graph, and I'm going to hope that it never hits the graph twice. And here it doesn't. So that's good. So that would be a function. Why don't you try 5, 6, 7, and 8 with your vertical line. Drag your vertical line across the graphs. See if it ever hits twice. If it does, that's bad. That would be not a function. And I would encourage you to pause the video, try these, and then unpause and check your work. All right, and as it turns out, every single one of these is a function. Let me just duplicate. Every last one of these is a function because the vertical line never touches 2 dots or 2 points on the graph at the same time. All right, there's our function video. Let me know what questions you've got. You can always send me an email.